All right, topic. I guess it's from session 4. We were talking about node fundamentals. 1. We were talking about module export and require, and event emitters, and node.js being a web server. So what we're gonna do is we're gonna take up this lab we had, and you can watch as I do it, just if you are so inclined, in case you missed something when we were actually talking during that session. So basically, what we want to do is get used to using modules and how to use them and how to use the export keyword. And then once we create these modules, which are encapsulated pieces of code in Node.js, encapsulation in a way that we can make reusable blocks of code, much like how we would use object-oriented programming and use reusable objects. We can do the same thing here with modules. And then it's just a way that we can put our logic in there and then make a bunch of not components, but again, modules that we can use throughout the application. Remember, there's 3 types. There's built-in modules, which are all the global modules in Node.js. There are the npm modules that we download from the registry. Those are third party, and then there's the custom modules that we can create for our own application logic. So this is what we're going to do today. We are going to create a custom module and just get used to using that. Exercise 1 says go and create a exercise 1 directory, but before that, we have an empty directory structure here. So we're going to make sure that we're in the right directory, which is demo. We're going to use npm. We're going to use init -y just to give us the package.json. Remember that file. That's the file that allows us then to start pulling down any modules or anything we might need. So if we just quickly look at that, it's empty. It's not empty, but it's just basically set up. The entry point is index.html8 index.js. If we were to say build this out to web application, that would be the entry point. Obviously, you can change that to server.js or app.js. So anyhow, we are going to create a new folder, exercise 1, just so we keep our code modularized, a little bit separated from each other, so we're not overwriting ourselves. And then next step is we want to make sure using those Windows commands that we need to change directory, dir to see that it's there, and then cd exercise 1. So we're changing directory to make sure that we're in it. And then the next step we said is that we're going to make a file. Now, in the example here, we said create a folder named sports team, but we don't need to do that because we're doing exercise 1. So however you want to lay it out, but I suggest doing it this way. So then we can create a folder called, okay, I see what they're saying. So they're saying inside of this folder, create an app.js file, and that's the file that we are going to is our entry point. And then what they're saying is we're going to create a module, and it doesn't have to be sports team. It can be module, it can be whatever you want. I guess for this example, we could call it sports team, I guess, sports team, but it's really a module folder. And inside of there, we're going to create an index.js. So again, this could be modules. If it confuses you, if just to make the point, we could say, okay, well, that is going to be called modules. Okay, that might make more sense to you. We were being specific, but okay, we'll name it modules. And then inside of the index, which is going to be the module, we're going to go and we're going to create a function. And now we can create a function this way. A named function called cheer. And we can use our ES6 syntax. Here in the example, we're using old vanilla JavaScript. So arrow function console log go plus this team. For argument's sake, we'll just say, and we should really be using backticks here. Let's use the ES6 syntax, and we can just say go Leafs go, just for the initial run, go Leafs go. So if we were to try to export this, it would be invisible to the caller. So you could actually do this module.exports, and then you can actually say cheer in that way. So then you can call it, and you can also do it the other way, which is you can do it directly on, like in this example here, export out each function. But there's many ways to export out functionality for a module, but there's a couple patterns there, especially if you have a lot of them built up. For this example, we can either do it this way, exports.cheer, or we can just export this entire thing here in this way. If there was more than one, then you could build out like an object, right? You could use like the curly braces, and you could actually put a list of your functions inside of there. But for now, we're just going to export this in this way. We're going to go back to this app.js, and in order to call this in, we need to, so we're going to call this module cheer for now, and we're going to require it. So when we require it, what that does is it's going to walk up and it's going to grab our modules, and it's going to look at the index.js, and it's going to pull it in for us. So when we do that, it's going to then allow us to, if we did it right, there's the cheer function. So actually, let's not call it cheer. Let's just call it sports team. Sports team is what we were calling it. So call it sports cheer, sports.cheer, and let's call this. Let's see if it runs. It may not run. You never know. Node app.js, and okay, so now it's throwing an error here. What is it saying? It's saying that it is saying sports cheer is not a function. It's not a function. Okay, why is it not a function? Because I think we capitalize it. If that's the problem, we'll check. It's always very case sensitive. All right, so now it's throwing another error. So this is what happens here. Cheer is not a function. All right, so maybe let's just go back to what we were saying here and just maybe just actually explicitly export this, exports cheer. And let's actually do that. Let's see if it's going to cooperate with us. It may not, you never know. All right, so there, explicitly, maybe I had done it a little bit incorrectly there for module exports, but there what we're doing, so we created that module, which was a function. Inside of that module, we had a function called cheer. We required that module, and now gave us access to it, so we can actually call into it. So that was kind of the first step on basically setting that up. And then as we go down here, we say 5 and app.js, require it, which we did. And in this way, we did something like that. So when you're using modules, you can actually use the concept of this because it has its own scope. So what we were saying before is inside this template literal, we could say $ using our template literal this dot team name. And inside the module in that scope, if you set it from the outside, it'll actually pick it up. So it gives it a little bit of reusability. So now if we walk up to this and we say sports dot team name equals Raptors, because I'm from Toronto, and then I say cheer again. Now we can put some reusability into that. Let's see if that runs. All right, go Raptors go. Again, if we were to say, put this back and say go Argos, I mean, who watches CFL really? I mean, honestly. I mean, I'm even from Toronto. I mean, not that I'm biased, but I mean, if I was living in the US, I'd be watching NFL. Anyhow, that's just me. Raptors, so go Argos go, and go Raptors, and then of course so it gives it a little bit of it gives me a little bit of reusability through that code. So it allows us to basically show that we can reuse this code in that way. I mean, we could certainly pass team name as a parameter and do it that way, but this just shows that there is a this keyword. So that was step number 6. Step number 7, which was to finish this little exercise, was declare 2 methods, boo and cheer, and call them from the app. So in the same way, it's just very simply saying that inside this module we can have more than one. We can also say exports.boo equals to, and again with this, if you do not have only one line of code, or again with the arrow syntax, you can just put it on one line, and you don't need to go through all that. So put boo and put cheer. So we already declared cheer. So it's just showing that we can walk up and give it another method inside of the module. These are actually methods, and expose them from the outside. And then if we want to then call it from the outside again, we can actually walk up and then and then call that directly. So here we have go Raptors go and then boo. Very simple. Basically, it just shows you how to expose methods from modules. Again, modules are reusable pieces of code. You expose them to the outside world, to the caller. The caller needs then to require them. And to require them, you can actually, once you require it, you can only have access to the explicitly exposed methods or properties. If they're not exported, then they'll be invisible to the caller. We also showed that you can pass in a parameter called this, but also you can also pass in parameters to the methods as you normally would. So that is exercise 1 on modules require and export. All right, moving on. So I think we are going to go a little step further, make it a little bit more complicated because this was pretty basic. Now we're going to create 2 modules with a caller, and we are going to add a little bit more to it, and just show how you can use reusable pieces of code like utility function and offload a lot of the work from your main file. You don't want to have a file that has 1,000, 2,000 lines of code. You want to basically do composition. Composition, it means breaking things into smaller pieces. When you organize your file system or your classes or your application that way, you want it very composable, reusable pieces of code in an organized way. Again, that's how you would architect a solution. You wouldn't want to put all your logic into one file that's 10,000 lines of code, but I have seen it, and you'd be surprised, but you don't want to do that because otherwise you have teams of developers all working in the same file, and it's just a disaster. So what you want to do is modularize your code. So exercise 2. So we're going to close out of this, We have the package.json there. We can close that too. Again, create a new folder. Exercise 2. Exercise 2, and it says we're going to have another 2 folders. One is going to be called calculator, I believe. Let's just say calculator. Create 2 modules called calculator, and then another module at that level called comparer. So we're just showing that you can have modules. Like you could have a top level module just called module, and inside of that you could have a calculator.js, and you could have a comparer.js. You could do that. Or you could also have folder structure and then have an index.js. However you wanna lay it out. Index.js. You don't have to do it this way. Like I said, you could put it in its own. Put all the modules in one root folder called modules, or again you can organize them a different way. So and it doesn't have to be called index.js, but I'm just doing it for this demo. So inside of calculator, we want to have, okay, first of all, inside of compare, we want to do this module.exports, and we want to, so we can actually export out. So we're going to export out something called r numbers equal. And what that is going to be, it's going to be a function that takes 2 parameters, x and y. It's going to console log quickly that you could say for your own debugging, say r numbers equal has been called, and then you can actually say $template x. Again, using template literals is so nice. You don't have to worry about concatenating everything. So this will be just for your own debugging purposes to see that you're actually calling the function. And then all you do is you're going to return a Boolean result because you're going to use this r numbers equal as inside a conditional operator, like an if statement, so you can reuse it everywhere. So it's just a way of reusing. If you're doing things more than 3 times, they say that is a good candidate for making its own utility or kind of reusable component, right? It's the rule of 3. So I'm going to quickly return x triple equals, because again in JavaScript equals is doesn't work as you expect it to work because of the dynamicness of type in JavaScript. You want to be very explicit. You want to say this truly means that x is a number and this number is equal to y, which is also a number. Otherwise, if you don't do the triple equals, you could be comparing strings. You could 5 double equal to string 5, which would still be true because on the fly JavaScript will consolidate the the type on you and you won't even know, right? So this is very explicit, saying X truly is is equal to Y. It's a very, very, very descriptive way of being very precise, if that makes any sense. Okay, so inside of our exercise 2, of course, we have this new module now, so we want to create another file, so we can call it app.js, and you can call it whatever you want, but that's what I'm going to call it. So I'm going to make a new parameter. I'm going to use const, which is a ES6 syntax. I'm going to say compare equals to require, and then you got to make sure you're in the right folder structures. So usually you have to say dot slash, and then you can see the modules there. I'm looking in the compare, and I believe I use index.js because the way Node works, watch when I run it, it won't work, but it'll actually look through the folder structure. It'll find your module folder, and it'll look for index.js. So you don't have to explicitly write it. So you can actually say, here's the folder. It'll be smart enough to look for the index.js. All right. So we have this compare set up. So we wanted to do something where we're going to call, what do we want to call the method? Down here we said create a method called, it doesn't matter what we call the method. So we're going to call whatever we'll call it. We'll just say, I'll rename it later. But for now, we're going to say constant calculator. Calculator, I think we said compare and calculate. I'll change it later. It doesn't matter what it's called. Compare and calculate equals to X and Y, because we're going to pass that in. And then we are actually going to do some conditional logic saying if these are equal, so you could actually do it in here like this explicitly. If X is equal to Y, they're going to say X and Y are equal, something like that. And then we could say or else, we are going to do something else. We're going to add them, I think. Console log, whatever it is. We are going to subtract. Not equal. X and Y are not equal. And then what we're going to do is we're going to subtract here. Subtract. We need some function that's going to subtract for us. And then here we are going to say if they are equal, we are going to add. Okay. So let's see if that runs just like that. And then of course, what did it do here on me? All right. So we want to invoke this function when we run it. Otherwise, it's not going to call. So we have to say compare and calculate 5, 5, and 5. And then we want to call it a second time, and we're going to say 3 and 10. Obviously, the first one should say they are equal, and it's going to add, and the second one should say they are not. So let's run this. Okay, we're in the wrong directory. Remember, change directory to get out, dir. Make sure you are in the exercise 2 directory, dir, and then node app.js. And it blows up on me epically. Why did it blow up? Maybe it didn't like what I said. Invalid token. Oh, of course. Okay. So again, with programming, it's always the devil's in the detail. And for some reason, it's not liking this. What is it not liking here? Let's just look at this error here. Invalid token R numbers equals. All right. So inside of this compare, it doesn't like this. It needs to have an arrow function because we're not using an arrow function. Okay, there we go. All right. So that's probably what we were missing. Let's run this again. Again, when you're working on this command line, if you notice I'm not typing, because if you use the arrow keys let you scroll through your last commands, which is really nice. You don't have to type it you don't have to keep typing it. So I scroll through it and I see, okay, I have this last call. I run it, X and Y are equal, X and Y are not equal. Great. So that is what we're hoping for, but we might need this comparison a lot, so that's why we created a module. So now we are going to implement that. So we are going to use our compare. We're going to get rid of this logical statement here and use compare dot our numbers equal, and we're going to pass in X and Y. So that module is going to take care of it. We may not know what that module is doing because the logic is encapsulated. Well, we actually know what it does now because we customized it, but typically you could call a module and not really know what the internal logic is. That's the power of it. You need to know. It should be a package that's given to you, and if it's a third party, you just trust that it works. and you trust that you can use it as an API, and that's why you're downloading it, because it gives you functionality that you don't have to hand code. You don't want to be hand coding a lot of stuff if you can find it out there. Unless you work in an environment where you have to customize everything and build it yourself, which I actually did work in an environment like that, and I gotta tell you, it was a pain. All right, so node.app.js, let's just prove that it runs the same way. All right, so it's still running the same way, and you can see now that internally we're actually calling it twice. So we're hitting that module, and it's actually working for us. So it's kind of like telling us we're inside the module. It's only for your own debugging purposes. You can go and remove those lines if you so choose to. Um, I'm dropping my ball cap here because I'm talking so much. I need a drink of water. All right, enough about me. So we wanted to then build a calculator out. So we wanted to build, so this is saying to us that we want to create two methods in here and export anonymous objects. So when we're talking about anonymous object, and I'll get that in a second, I'll change it in the way that they want it to be changed. But firstly, we can do it this way. So we can actually export out add equals to a function that takes x and y, and it's going to be an arrow function, and it's going to return. Again, you can console log in here if you want just to test it out, or you can just say, okay, I know it's going to work. So x and y, and we're going to export out another method called subtract that is going to take two parameters, x and y. It's going to use an arrow function, and it's going to return x minus y. I mean, if you were really building a third-party module, you can do a lot of error checking here. You can truly check that x and y are numbers and they're not any other value. If they are, then you return false. You could go through all that, but for our demo here, we're just taking it. We're assuming that they are those integer values. Otherwise, you could get errors. Okay, so now we have two methods exported, and we're going to go back to the app.js, and we're going to also include that. So that's our calculator. Calculator equals require. Again, it's going to pick it up. Calculator is going to walk up and it's going to pick up the, it's not walking, it's just going to find it. It's walking up the tree, the source code tree. That's what I mean. So it's going to require and look in the calculator folder. It's going to see if there's an index at h.js. If there is, it's going to use that. So now on calculator, we have two methods that we can now use, right? We can use calculator.add x and y. And it's going to, we should actually, if we don't console log this, it's going to not do anything to our console. It's going to add it, but I make that mistake all the time. It's not going to actually give you the result. So you can console log that, and again, at the same time, you can console log calculator dot subtract x and y. So if that is a little confusing to you, you can actually, I mean, for code clarity, you could say constant. You could say the sum equals, and then cut this out if that makes more sense to you. If you want to have clean code and you want to see exactly what it is, you can do this. So it makes a little bit of sense to you, because sometimes with these multiple parentheses here, it gets a little bit, it's hard to keep track. It's very easy to create errors. So you can be very clean about your code and separate that out. It's not a problem. It's not wrong. It's actually very good in some cases to actually see what you're doing. So there you go. So we have the difference and we have the sum. To me, it clearly tells a story of what it does. Again, when you're writing programming, your methods need to be very descriptive. It needs to let some other developer or someone looking at your code know what that means. So when I see compare and calculate, and I see our numbers equal, and I see adding is the result. It's a sum and a difference. I know exactly what this does. If you just say I'm gonna say it does something, or delete all data, which is really scary to be honest, or core dump, or some ridiculous name, it doesn't help you and it's really bad programming. So you need to tell a story, and you need to actually be very descriptive in what you're actually doing. So if somebody were to read this book, they would know exactly what you mean. So if I go to run this, let's cross our fingers, and it looks like it runs. All right, great. So when we talk about anonymous object, I'm going to pause this because I may get this. It may not work for me sometimes. Sometimes again, the syntax is off. So if you see what that means is, it means is instead of exporting in the way we were doing, export it in this way. And I did try to do it in the first example, but I didn't get it right. So it says module.export equals, and then you give it an object. So it's kind of like an object literal. If you remember in ES6 review and JavaScript review, there was something called JSON objects and object literal, which is an object with a key value pair. So in this way, this is what it's saying in an anonymous object. It doesn't actually have a name. You're just passing an object back and forth, and inside of that object, there could be a key value pair, which just happens to be a function name, and a function. So that's is another pattern of exporting. And let's just try to do that quickly because that was part of the exercise if you didn't know what it was. So going back to compare calculator. So instead of doing this, and it actually is good because you don't have to keep doing the export keyword every time. What they're saying is, or what I was saying because I wrote this, module.exports. Exports. Okay, now it is actually giving me some IntelliSense, but it's not giving me the coloring for some reason. Maybe because I have an extension going. But so I set this to equal. All right, so now it's an anonymous object. We need to fill it up. So we could cut this here, and we can put it inside of this module, like this. But now you see it's giving me an error because that's not the format it's expecting. It's expecting, we already have exports, so we can get rid of the exports. And now we're inside of the object. So the semicolon doesn't make any sense. It needs to be a comma because we have different key value pairs. All right, so that is looking a little bit better, but it's still going to throw an error because it needs to be key value pair with a colon. Again, this is an object literal, and this is an anonymous object. And if you don't get this, to be honest, if this is too far of a departure, you can just do straight module.exports on the function, and that's perfectly fine. Sorry, export.function name like we did here. That's perfectly fine. This is just showing you that you could have multiple. Now, if you have 100 different functions in here, you just export the whole thing. All right, so provided that works, we should be able to walk up to this. Again, go back to this file and run it. It should work still, and it does. So basically that's what showed a way of having multiple modules, exporting them in different ways, and then including multiple modules into your main caller file, and just showing you how to create composition and reusable pieces of code, and creating different kind of modules and including that in your main caller file so that it doesn't end up being 1,000 lines of code. You're organizing in a very nice way. It's very clean code, and again being very descriptive about what you're doing and telling a story with the function and the coding you're doing. All right, we'll move on to exercise 3. All right, moving on. Exercise 3. Using event emitters and events. So again, what we talked about previously was the event-driven architecture of Node.js and how we have very big and famous concepts that's known for like the event loop and things like that. And just knowing that now this is server-side code, and basically we are mimicking what the UI has done with event-driven kind of design. Now we're taking to the server, and we have use of all this great stuff that we can trigger and we can broadcast, and we can be very asynchronous and non-blocking. So just getting used to using event emitters is very powerful because you can use them and they're used throughout the entire Node.js, where it's very simply something like creating a file and closing a file, and basically events and triggers that can happen off that. Long open a connection to the database and close it and trigger things off of that. So there's a lot of things you can do. It's very event driven, like I said, and this is just getting used to using event emitters and creating your own. So the first step, I already took the liberty of creating a folder and index.js, so we're good, which maybe I'll just call it app.js because that kind of is more descriptive of what we're doing. It's not really a module, but that's not wrong. So we need to include event emitters, and again, there's a documentation on npm Node.js about what that is. Event emitters, that's actually a package there, but it has a lot of great stuff. But it's built-in module to Node.js. So you have to first say var, create your keyword and then require it, bring that module in. But it's a little different how you wire it up. In order, you have the events package, the events library, but in order to get the emitter object, the emitter class, you need to instantiate new events dot event emitter. So you have a new a new object, a new instance of event emitter, and that's a step I always forget. So I already have that, and I'll copy paste it through the magic of of technology here, and I can pause the video and stuff like that, so it doesn't look like I'm pausing as much. So I already had that saved. So now I have an event emitter, and what we want to do is we want to create two event handlers that, so basically it says, create event handler to handle when an event is raised. Event handlers are written in a way as a function expression with the following signature, and they can be wired up in the following way. So if you look at that, it's saying that you can create a function, that's a callback function, and then you wire it up. You say emitter.on, so that's setting up your listener. So when something triggers call, it's going to look at, it's going to catch it, and it's going to try to run the callback, which is function, which happens to be this, and it's going to console log call me. And that listener is just going to sit there and listen. And it may never fire, it may never get triggered, it may just simply be registered. And some obscure event may happen at some time. If something does emit call, that listener will catch it and then execute the callback function attached to it. And that's kind of what an emitter is. So you may have many listeners set up for different events, and they may all be dormant, and maybe one might trigger, and they may trigger off of that multiple events. And they may call each other, and they may do a lot of things, right? So basically that's what we're talking about. So we wanted to create something called alarm. I know I'm thinking ahead. So we're going to have something called a caller. We're going to have a call handler and an alarm handler. So we can, in that same function now, I want to use the ES syntax where possible. So this var keyword, again, is vanilla JavaScript. I want to lock it down. Using constant means that it cannot be overwritten anywhere, just to get in that good habit. So constant. So if we wanted to say constant, we're going to create a handler, function handler, callback. Alarm handler, we'll just say for now. And we'll use that ES syntax arrow function, and we're just going to say console log call 911, because that's an alarm being raised. I'm working ahead a little bit because I know what we have to do. I'm going to say a call handler, which is the same syntax here, and we're just simply going to say console log call me when you can, but just call me, really, as I was saying. So all right, so we have two handlers here. So now what we're saying is we could set up our event listeners. And this is where we set up our signatures. We go my emitter, event emitter, sorry, dot on, and then we give it a named event. So basically it's a string, and we'll say call, and we're gonna say call handler. And if you notice, we're not gonna invoke it like that because that's gonna throw an error. So we're passing it by reference, and what that means is we are giving it the reference to that. Sorry, we are giving it the reference to that callback, to this callback function. And when it triggers the callback, it's going to know that by reference that is the method that's going to have to be invoked. So if you don't need to invoke it, you just need to pass it, and pass it by reference. It's like C passing by pointer. If you ever worked with pointers, it's a very confusing concept, but basically you're passing a pointer to an object. You're not passing the object, if that makes any sense. So we want to set two of these up. So we're going to do on, and we're going to say alarm, and then we want to say alarm handler. And now we have two listeners set up. But if you run it, we will run it quickly, and we'll say node app.js. It's not going to do anything. It's going to exit because we haven't triggered it. So in order to trigger it, we need to say emitter.emit, and we're going to say call. So now when we actually execute that, it's should do just call. So if you notice, it says call me. It doesn't call 911. So we could actually, if we needed to do that, we would have to emit it again. So this is our emitter, and we'll just say this is our emitter, emit events, right? So we would have to just do alarm, and then we're going to call it and run it, and now it should do what do we expect. Okay, we need it to be a semicolon, and we can go like this. So we have something working as expected. We're saying alarm has been triggered, 911. So we have the event handlers listening. What did we say? That was part 3. Part 4 is create a second event handler okay, so it says create a handler. So we have 2 of them that will be emitted when the first one is triggered. So what it's saying is we can change this text here to say just what the exercise says. Alarm has been triggered, right? And then what it's saying is we want to trigger, we want to emit the first event, and then inside the first event, internally inside that event handler, trigger the next one. So that when we emit call will catch it, and then internally call will trigger the alarm. So we can actually have some interaction going between the callback functions. So we can get rid of this. And by the way, there's a short form here. You can actually do chaining. You can actually do dot on in this way for a short form. The other way is fine, but this is just a short form. So it kind of chains you'd have to get rid of a semicolon. So it's just a shorter syntax, and you can wire up as many listeners as you want. When I press save, I have prettier, so it's actually putting on one line. So the task is to, inside of this call handler, we want to use emitter, event emitter, event emitter, and we want to say emit, and we want to say alarm. So now what's going to happen is when we emit call is going to do the callback handler, console log alarm has been triggered, and then it's going to emit alarm, which then will this listener will catch that, and it'll look at what callback function it is, which is alarm handler, and then it's going to invoke alarm handler, and alarm handler is going to do console log call 911, and that's kind of what we're expecting to do. So let's run this. So if we get the alarm has been triggered, call 911. So this is just showing how you can use event emitters, how we can use that internal module, how we can set up event listeners, how we can emit events, and also how the callback function handlers can also interact with each other. Because I could very easily have inside of the alarm call handler again, and then we get this crazy back and forth. Let's just do that. Why not? Let's just see what happens. It won't exit until I force it to exit. It may just keep running until maybe until resources run out. Who knows? Let's just see. It's an infinite loop, which is never good. And if it blows up my machine here, then if this video stops, you'll know why. So here, let's just run it. So look at this. It's going crazy here. Alarm triggered. Alarm. It's gonna go until the kernel basically runs out of resources, or unless I do Control X. Oh, it basically stopped. It was probably smart enough to know that it could not keep running. So there's probably some mechanism inside to prevent a run condition. So that's great. I feel very safe now that my expensive laptop is not gonna. I'm not gonna have to take it into repair because the fan is already not working with all this video conferencing I'm doing. So rest assured, I can sleep easy tonight. So that's exercise 3 on event emitters. We're going to talk about Node.js as a web server in just a minute. And let me just take a break. All right, exercise 4. I took a break because you know what? Honestly, I don't know how these radio hosts do it. They talk for 2 hours. To be honest, it's a little bit tiring. To be honest, you need to take breaks here because we're probably gonna go for an hour. It's already 40 minutes. It's probably gonna be an hour doing these exercises. But you know what? They're good, and it's I can just take a break here and come back. So it's really good for me. Anyhow, exercise 4. So we're talking about Node.js as a web server, how you would want to create a web server, and how great Node.js is for networking, and how in a few lines of code here, we can easily create a server that handles HTTP requests, which is fantastic. Again, as we talked about previously, that may not be the case. Those 20 lines of code, although it may look simple, and when I first looked at it, I said, is that all Node.js? Is that all there is to Node? Is that it? There's not much there. And if you look at it, there isn't much there, but the power of it is when you use that HTTP module and you use create server, it creates a server that's ready to listen on the port and host name, but you don't know necessarily all the heavy lifting that's happening behind the scenes. Again, this is a wrapper, this JavaScript is syntactic sugar that is a wrapper and gets transpiled down by the various engines like V8 and those engines there. It gets transpiled down to C and C++ because Node is written in C and C++. It's not written in JavaScript, and then it has internally to its architecture things like libuv and things like that that deal with the I/O, and those things are the things that will open up the connection and create a server. So at the very top level, you got 20 lines of code and you're ready to go. You create server and you set up the listening and you got something that's ready. How great is that? That's, it blows me away. If you've worked in other frameworks and see the pain or other runtimes of trying to create a server like in .NET or something like that, there's a lot of work that goes into it. But this out of the box has 20 lines and you're ready to go. So I took the liberty of copying the code. I'm all ready to go. I already have it running. I actually named my file server.js to show it doesn't have to be called app.js all the time. Node server.js and it's running. So if I go on that port and I refresh it, it's going to say, well, it's going to say it didn't actually, I did not actually rerun it. And that's a case here of using NodeMan. So it didn't catch my change. So let's say this. Control X, Control C to get out of this, Control C. And I want to use that node monitoring tool, which will pick up my changes on the fly, and I don't have to keep stopping it and restarting it for a build. Because if you notice, I made a change and I went back to it, but didn't catch my build. So now it's going to monitor that file. It's going to be watching. So right now, if I refresh it, it should say hello world, which it does. Great. So now if I come back and change it to slot machine, you'll notice on the bottom there, that node monitor will pick it up and rebuild without me having to stop and run node again. So if I go and refresh it, it's going to automatically say slot monitor. How tired am I? Slot machine. Talking about low node monitor, not anyhow. I'm just tired. Slot machine. That's what I want. Slot machine. So we're trying to talk about spin and play and things like that. That's what we're talking about. I don't know why I'm thinking about online gambling. Being at home so long here, I guess I'm thinking about things I can do online. So, all right. So once we have that running, it's going to show us part 2 is what we did. Start the server up. It's going to be waiting. It's going to open up on port 33,000, and you should have hello world, which we did. And that was exercise 4, just creating and getting set up with this this create server, which we have. So that was pretty short. So I feel good enough that I have enough energy to go through exercise 5, which was create a slot machine, not a slot monitor. I don't know what that is. A slot machine. So we are going to use a slot machine, and it's just a way that we're just basically catching the URLs and basically showing that with the HTTP module out of the box, you can handle the request. The request could be what the URL says, and by default, it's a GET request. So internally, it'll give you the request, and you can actually capture that, and you can do some conditional logic on that. And that's what this exercise is. So you want to kind of look at something called the query string, and the query string is this localhost 3000/spin or localhost 3000/play. That's the query string path. You can have query string parameters, which I'm sure you've seen with the question mark, and then I hope you don't see bank information in there. I certainly don't hope you see passwords in there, although I have seen it. Maybe, if you see a site like that, don't give them your credit card information. So what we want to do here is we want to have, as we're changing the URL, we want to basically we want the console log the different changes. So that's what we want to try to do out of the box. So if you notice now, if we were to actually hack the URL and do /spin, and if we do /play, it's going to return the root level, and that's by default, and it's going to go through there. And one thing I didn't notice, inside of this HTTP object, there's a create server, and there's a callback function, and usually the pattern is request and response. REQ stands for request, and REQ stands for response. So if you hover over it, it'll give you an indication to what it is. REQ is the incoming message, which is the request. It says it's never used, which is fine. And the response is the outgoing server response. So right here, we are actually saying on the outgoing server response, when we have that default request, it's going to return a status 200, which is okay. It's going to set the header, which is plain text, and it's going to return the payload, which is slot machine. So if you don't know what that means, I'm going to expand this for a second here and go to my dev tools. And you can actually dig into the network tab. If you don't have any experience with this interface might be a little bit foreign to you, but it's very powerful. So you can actually look at the network tab and refresh this, and it'll actually reload. And you can actually see some things going on in here. Normally on a website, if you try this, you'll see a lot of interaction going on. And now we have some things here. We have some text static items like the fave icon, which is this little eye here. And we have another document here and a script that ran. But we really are looking for is this document right here. If we click that, it'll expose the header. And that status code there, 200, corresponds back to our 200 here. And the content header type is right here, plain text. And the slot machine is the payload. So this is the response. It's right there, and that's what gets displayed in this screen. So you can actually dig into a lot of different things. If you look at a very interactive site like Amazon, take a look at the network tab, see what's going on. There's a lot going on in there. So we can close that out. That was just some debugging dev tools to look at. But what we want is we want to be able to handle the different query strings. So what we can do is we're not using this request, but they're actually on the request. If we console log request.url, there's actually a URL object on there. So if we save this and output it, all right, let's just see if this works, because you never know. And we go play/play, it's undefined. Oh, because I didn't do URL, I did UR, and then I need to have a bracket, a parentheses. All right, so if you see, it is actually giving me not what I expect, to be honest, but let's see play. It's saying /play. All right, it's referencing socket.io. It's doing something with that, which is strange, but there must be something running that I have running. That's probably why I have something running in another thread. Anyhow, we can ignore it. Look at it, it's actually polling. I must have something running in another thread, which I probably do, to be honest. Let's see, do I have something running? Because that would be very strange. Do I have something on another terminal? No, I don't have something on another terminal, but it is catching something. Maybe there's a socket connection running in the background. Anyhow, I was playing with socket.io, so it is running, but nevertheless, we can ignore that. We don't need to console log it. We can just say if the request URL equals to play, we'll ignore the rest of it, and we will console log out, console log playing. Otherwise, else, and again we have to do else if request.url equals to spin, and if it's equal to spin, it's going to console log out spinning ... and that's it. And we can get rid of this line here and basically ignore everything else. It should be quiet. See if you notice, now it's going to be very quiet. So if I come to the URL and say play, the console log should say play. If it doesn't, I'm in trouble because I need to look at my code here. It's not saying, why is it not doing that? So let's do slot, let's do spin, and it's not doing anything. So you know what? I need to do the power of pausing here and debug a little bit. All right, of course, small problem. It's always the small things that make the biggest issues, right? So of course, it's not looking just at the word is what I was thinking. It's actually looking at the whole query string, which is /play. So what I was missing was that slash. So it was being very explicit. That's what being very explicit means. You could do contains, right? String contains play. I could have done that. That would have been probably good. I could have actually done it in that way, but yeah, I could do that. But if I was being very explicit, then /spin is what I need. So now if I actually start changing the URL on /spin, and I go back to /play, and it's back to /spin. So you can see there that the URL is actually changing. The URL is being caught in this conditional statement, and the console log is actually updating. And that's that on that one. So exercise 5, I'll take a look at that. That was a challenge. So the challenge for exercise 5 was build this thing out a little bit more. And what did we say here? We wanted to actually get you into the query string parameters. So if you were to actually use, if you were to actually put an amount in there, you should be able to grab it. And what you need to do is you need to use console const URL which is another package for URL. And what that does, it allows you to dig deeper into the query string parameter, and you can actually parse out the data in that URL. And you can basically, if there's some, so if we were to now go to spin and say question mark amount equal to 25, it's not going to do everything because it's not going to find it anymore. So we need some mechanism now to split out those two things, and I'm gonna have to look at the API lookup quickly. It's and just see how to do that. And I won't waste time here looking through it. I'll be back in a second. All right. So what that looks like is, again, this is a challenge question. What it looks like is you can actually use URL and parse the request URLs, and that will give you, if we look at parse, it'll say query string 2. There's a bunch of things. So that's going to give us the entire query string. And then inside of that, it's going to give us an object, and we can actually get the path, we can get the query, and we can get whatever parameters there are. So let's just console log URL parse what that returns, and then based on what that returns, we can dig through this. So let's look at this here. So there you go. So what that does is it parses everything out for us, and we have this big object now. And this big object here, look at this. This is giving us everything we might need on the query string. Look at that. So URL, slashes, hashtag, search itself, the query object right here. That's what the query object looks like. The path name. So this is a socket.io. So socket.io is still running, but nevertheless, this spin would give us the same thing. So it's giving us a lot of information there. And it's because that socket.io is running in the background. That's why it's doing that. But it's giving us a lot of information that we can pull from, right? So we could use that. See, it's running because something's running in the background. But what we could do is we could say something like this. Let's just move this above here. So we're going to use this URL parse, and we are going to put this at the top here, and just so we can cancel that noise out. And we are going to put it at the top here, and inside of this URL parse, there should be a path name, .path name. So that right there is going to be the path name, which is the same as the request.url. So URL parse .path name. So now we have that information there. And then we can start digging into those other, what we want to grab is that amount in the URL, and we want to output that to the screen. So we want to get that data out of there, right? So we have constant, I forget what we said. We said URL, we said parse data equals to URL parse dot, where was it again? Was it query? It's query. So get the query string, and then based on that query string, we're going to pull out this thing called amount. So let's console log parse data from the query string. Parse data, let's console log that. Console log parse data, and then we assume that on that object, when we say spin, we are going to get this object here, which we should get something. If we don't, then that's a problem. So it's not actually, oh, I'm sorry, play. It is actually doing it as expected /play. So now it's returned an object, as you can see, that has an attribute called amount. So now I can dig into that further, and I can say constant amount equals to parse data dot amount, and we can console log that amount. All right. So now if we trigger this, it should actually, didn't like that for some reason. Parse date, of course, because again, I'm misspelling it. So let's do it again. URL, and it's grabbing it, right? So it grabbed the 25 out of there, and it's doing what we want. So you can really use that library. So let's look at the finished code here, just because it's getting late and we keep going, we're going and going and going. So here's the finished code. Let's get rid of this. We have URL parse, which has access to path name, which we can check for the path name. We can set the query data, we can set the amount, and then we can output the amount. If the path name was spin, we can actually have some spin. I think the exercise was if it equals to max, then say jackpot Otherwise, say you lost. So we can check that the amount is string max and then console log a jackpot. Otherwise, say that we lost. You could actually have a total, a running total, and you could decrement it, like you lost money all the way until, like, you could make this more complex. Otherwise, if it doesn't do anything, you set the amount to 0 and you say please play again. So that's an example, again, a long-winded example of the challenge, but basically showing that you can use Node as a server. You can pull in the HTTP module, you can pull in the URL module, and baked into those you have lots of functionality that you can dig into the query string, do all sorts of stuff with it, get lots of data. And basically this just shows you how Node can be a networking tool, which is very powerful. It's great along with Socket.io that we're going to talk about in another lecture. Socket.io can do some really great things like gaming and gaming and collaboration tools and chat windows and these kind of things. So the lesson here is Node is great for networking. It's very event driven and we got a lot of great stuff. And it's been an hour now. I've been talking too long, so I'm just going to sign off on that. And that was lab number 4. All right, thanks.